No screaming now. All right, one sample t-test for slope. Please fill that out in your table of contents if you're someone who's taking table of contents. If you're not, we'll just get going here. I'll read through the problem. Again, I want to remind you that I'm taping, so. Do customers who stay longer at buffets give larger tips? Charlotte, an AP Stat student who worked at an Asian buffet, decided to investigate this question for her second semester project. While she was doing her job as a hostess, she obtained a random sample of receipts, which included the length of time in minutes the party was in the restaurant and the amount of tip in dollars. Do these data provide convincing evidence that customers who stay longer give larger tips? Here is the data, okay? So part A says, here's the scatter plot of the data with the least squares regression line added. Describe what this graph tells you about the relationship between two variables. When you are doing anything that says describe, you do need to say suds or socks or whatever word I taught you, sucks. So if it's a one variable distribution, which would be like a dot plot or a histogram, you use socks or socks, okay? Shape, outlier, center, spread. If it's, so this is AP prep right now. If it's a skewed distribution, what should you use for your center? The median, and the spread would be the what? What goes with the median? IQR, very good. Okay, the IQR. All right, and then if it's a symmetric distribution to describe the center, you use your what? Your mean, and the spread would be your what? Standard deviation. And do you remember, I think Danny asked yesterday, do you remember how to get it on your calculator? You want to become one with this calculator. So, do you remember how to get that? L1, stat, calc, one variable stats. Anywho, let's talk about this one though, because this is bivariate data, so two variables, and we talk about suds. We're going to say the shape is linear. Is there anything that might be unusual? What do you think? Yeah. Maybe this one? Okay. The direction is what? Positive. The strength is what? Yeah, I'd say that's like moderately weak. Yeah, weak enough. We're going to write this like we're writing it with the correlation. Okay? Some of you on the test, I didn't dock you for this, but writing just S colon U colon D colon S colon isn't okay. You do need to write it as a sentence. You would say, there is a weak or moderately weak positive linear relationship between X and Y, so time and tip. Okay? What did we get from the suds? We got the shape, the direction, and the strength. What we didn't get was the potential outlier. We have a potential outlier. At 40, comma, or is that 40? Must be 44. 44. Oh, 39, yeah. 39, 2.75. Again, reviewing because this test didn't go as well as I would have liked. What does an outlier do to your correlation? It weakens it. So if I take that correlation away, it strengthens it, okay? A few of you wrote the oval test, so I was actually kind of happy to see that because that means you're listening to me. I'm not certain. I need to talk to another AP teacher if that would be like a legitimate term to use on the AP stats test. Instead of saying the actual oval test, that's just my way to like really, it's a good visual for you guys. You could just say the points are closer together or wider apart, okay? I think that would be a little bit more technical. Scholarly, sure. But I did not dock you for that oval test, and I will check on that as well. I did learn the oval test from an AP workshop, so we'll see. Questions there on describing a scatter plot? Again, that's review. Moving on. Oh, and then we got there, okay? Moving on. Is there part B? Am I missing a part B?
Yeah.
What does part B say? Oh, there's not. So we're missing a part B. Okay, so let's go on to C. What is the equation of the least squares regression line for predicting the amount of tip from the length of the stay? You will see a mini tab output. Again, a reminder of what everything is on here. Tip is your Y. Time is your X. How do I know that? Look at the graph or think which one is explaining the other one. X is explaining a Y. Okay? Next, time is your X. This is your slope. Your constant will always be your Y-intercept. Right here. What is this right here? We do need that from what we learned about the confidence intervals. What is that? That's the standard deviation of the slope. Okay? The standard deviation of the slope. So a review from Tuesday, which seems like forever ago, on the side, the confidence interval, without going through all the speak, plan, do, the basic confidence interval for slope would be this 0 points, and I can't see it because of my circles, 0.03013 plus or minus the T star for what degrees of freedom? Remember? N minus 2. So we have to go back and we have to say, well, what's N? That's how many pairs we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I think she says that in her problem too. So we go to our chart, 95% confidence, degrees of freedom 12, find that T star, and then our standard error of the slope is here, 0.2024448. And you, again, review from Tuesday, you have to take the statistic plus whatever this is, and the statistic minus whatever this is. Yeah, question, Danny?
So for the first part of the confidence interval, you use the slope from earlier?
The slope from the output right here, 0.03013. Okay. The y-intercept is the constant always. Right below it is the slope. Okay, the 0.03013. And again, that's from Tuesday, and it's pretty slick because they're going to give you everything. They're giving you the slope. They're giving you the standard deviation. You just have to find that T star from the chart. Okay, if you need help with that, make yourself a little note and ask me. And then you just have to like plug and chug, basically. Type it in your calculator. Right next to the slope is always your standard deviation of the slope, yes. Our S is the standard deviation of the residuals. You have to have that definition memorized. Your R squared, you have to have that definition memorized. It's the variation in Y that can be attributed to the least squares regression line of Y on X. Yes.
What is that?
S is the standard deviation of the residuals. So it's your average prediction error. So when I'm using X to predict Y, okay, when I'm using X here to predict Y, on average, I will be off by about that much. That's the standard deviation of the residuals, and it should be in your notes. In fact, I think we're going to do it again here just to review. I will have to get copies for you. I'm sorry. Okay. Let's go through, though, and do the least squares regression line. So the least squares regression line, Y hat, so your Y is your tip, predicted tip, is equal to your Y-intercept, 4.535, plus 0.03013 times your time. Questions there? So those of you guys who haven't taken the test yet, this is good review as well for what's on the test. Yeah, Eric? You do have to have the hat. That's saying that it's a predicted value. Okay. Any other questions here about the input? Common mistake on the AP test, that R squared, we've talked about it several times now. But just to review, How do I know if I don't know anything else? Like I don't see a graph or anything. I don't see any problems other than the output. And I get an R square and they ask for R. How do I get that? Square root. And then what do I have to look at to know the sign? The slope. If the slope is positive, the R is positive. If the slope is negative, the R is negative. Okay, very good. All right, let's move on. Interpret the slope in the y-intercept. I have it down already for you. Again, write it down again because some of you don't have it memorized. Chapter 3 was kind of a, we're almost at the end. I'm a senior. I'm having a hard time keeping up my stamina. So write it down again just to get the practice writing that. The model suggests that for each additional minute that a party stays at the buffet, the least squares regression line predicts an increase in tip of 0.03. Okay? I'm going to pause it while you guys read. All right. So those of you who are watching the video at home, you need to pause this and write down the y-intercept. We've already talked about it in class. Okay, now you're going to want to go to the next page. And I just recopied everything I believe that we have onto the next page so I don't have to like flip back and forth. But now what we're going to do is instead of a confidence interval, we're going to do a test. And we have one, yes.
Is this another cutout?
No, this is all the same information. I just like put it for, like, I copied it onto the next slide so I can still see and I don't have to go back and forth. Do you have part B on here?
No.
Okay, just write down a one sample t-test for slope beta. And part B says carry out the appropriate test to answer Charlotte's question. So this is all the new stuff for you guys right now. I know it was a lot of review there, but again, the test didn't go as well as I would have liked. So that's why I did that. So while you are writing this down, what I wanted to just say about it is what we're trying to do right now is remember when I was talking about confidence intervals. We get a positive association. There are one of two reasons for this positive association. It is either because there's an actual positive association, but we have to prove it, or it just was by chance that time, okay? If you're going to prove it using a confidence interval, that there's an actual association, what don't you want in your confidence interval?
Zero.
You don't want 0 in it. That gives us evidence that there's an association. We're going to do it with a test now, okay? The first part would be the state. Your state is going to have your null hypothesis, your alternative hypothesis, and your parameter. What is your parameter this time? I know, it's beta. This is your true slope. Just like we would have our true population proportion or our true mean, okay, of the population. Now we're dealing with our true slope. So in the state part, what I'm expecting is I'm expecting a null, an alternative, and then your beta. For all hypothesis tests, the null hypothesis will always be beta is equal to 0. Okay? Beta is equal to 0. We assume there is no association. We're trying to prove that there is a significant association. Now we just need to look for keywords. Is it asking, is there a positive association? Is it asking if there's a negative association? Or if it's just saying, is there an association? What is the question asking? So we have to go back to the actual question about Charlotte here. And Charlotte says right here, do these data provide convincing evidence that the customers who stay longer give larger tips? So what are we trying to prove? There's a positive association, which means we're going to put beta is greater than 0. Again, thank you for listening. Keep staying with me. We only have one more day of notes after today, you guys. Beta is the true slope. Guys. the true slope between time and tip. How did I know it's greater? Again, she's trying to prove that the longer they stay, the larger tips they make. And so that would be a positive association there. You look for those keywords. If you don't see any greater than or less than keywords, it's a not equals to. Our plan is our conditions and our method. The conditions are annoying, but thankfully you will most likely be given all of this, so you just have to say see above, okay? So, liner. L. Is our relationship linear enough? Is it straight enough?
Yeah.
Yes. And C above. You do, because you're supposed to show it. I is the same independence always. 10 what? 10 is less than what? What is this problem about? People who are going where? To the buffet. So all people at the buffet. And because it's we should say a buffet like what? Like this one, yep.
Why is it all people at this buffet?
All people at buffet like this one?
Yeah, why is it all people at this buffet?
Oh, sure. You could say that one too. That's fine. What does N stand for? N stands for normal, and it's a histogram or a probability plot of the residuals. I believe they give us a probability plot. You have maybe not seen that yet. The probability plot is right here. Okay? And what you want with this probability plot is you want it to be straight enough. Is it straight? It's straight. So, probability plot above is linear or straight enough. E is the equal variance. That's your residual plot. That's where you want to look at this residual plot and say there should be no pattern. The variation on the bottom is equivalent approximately to the variation on the top. Okay? No pattern. So if you would draw a line from it, you see kind of like some kind of sine, cosine, little up and down wave, right? You don't want to see a U. You don't want to see a fan where it would go, whoop, okay? Questions there? So we say residual plot above has no pattern. And then R stands for what? Random. And she stated that they were random what? Random receipts. And then, yes. E stands for equal variance. So that means the residual plot. So I guess if we wanted to change it to ln r squared or whatever, that's fine too, but it's dealing with the residual plot. And then finally the method. Always ask yourself with the method, how many samples are we dealing with? We're dealing with one sample. It's either a T or a Z. We're dealing with quantitative data, which is means. So that's going to be a T for beta. I'm going to pause it. I hope I didn't go too fast right now. I'll just see if you have any questions. Okay, let's finish this up. The do. Again, guys, they give us everything. I don't have my cutout in front of me, so. For the do part, you need a T-score. You don't have to draw a picture on this one, guys. Just give me the T-score. Well, Tom's zoms, or observation, what are we dealing with here? What's the scenario? We're dealing with, what statistic are we dealing with? We're looking at tips versus time, and we're investigating if there's a relationship by looking at the what? The regression line. And what's important about that regression line? The slope. We're looking at the slope. Okay. So the actual statistic is B, the given slope. Minus the mean. What is the mean? What is the parameter now? What is the mean? That's our beta. Okay? This always comes from the null hypothesis. Divided by our standard deviation or standard error, which is on the computer output. So RT, okay, RT is 0.03 minus 0 divided by our standard error, 0.02448. Can someone calculate that for me, please? And thank you. We're almost done, you guys. You're doing a good job. What did you get? 1.23? Yes? Okay, and now what do you notice? Look at your computer output. They even give you the T. I was just trying to show you. I'm sorry for those of you who are annoyed. They give you the T value right there, 1.23. Your degrees of freedom, they do not give you. Your degrees of freedom, you have to find. We've already talked about it, n minus 2, so 12 minus 2, which is 10. And then finally, our p-value. Now, there's an important thing with the p-value that you have to know. The computer output does give you the p-value. I won't make you go to the chart and find it. Here's the p-value right here. 0.247. But the key is here, this p-value is always for an alternative hypothesis where it's a not equal, a two-tailed test. So what do we have to do with that p-value since we have a one-tailed test? We have to cut it in two. Okay, so, and I wrote that here. For a one-sided, if it's greater than or less than, the p-value has to be divided by 2 because the output always gives us a two-sided test p-value. So I need to take 0.247 and divide it by 2. And that's like 0.13 something. What is that? No. 0.11. Did someone calculate it? 1235. Okay, so let's sum up the do. Again, you guys, please, chapter 12 is not bad because the computer output gives you almost everything. We have the formula for the T. Yes?
You show your work on this.
You do have to show your work.
So like, you know the computer gives you what it is.
You still have to show your work. You do. It's not too bad, though. You don't have to show this up here. Okay? You just show right, I'll circle kind of what you need. And to be honest, you probably don't even need to show your work here. You don't need to show that. Just do it in your calculator. That's not a problem. Okay? All right, and then finally, this is our grand finale here, our conclusion. Because our p-value is approximately 0.1235 for a t of approximately 123, we don't need to put that. I did that last year with the kids. Let's retype it the way I have it this year. Same conclusion as always. Because our p-value, which is approximately 0.1235, is greater than alpha equal to 0.05, we fail to reject H naught. We have, can we talk about H naught here? No, we have to talk about HA. We have no evidence to support HA, okay? So we have no evidence to support that the true slope between time and tips is greater than 0. While you are writing, a follow-up question might say, what would you predict about a confidence interval here? Because we rejected, what will the confidence interval have? It will have 0. I want to give you a friendly reminder. If you have a follow-up question about that, you have to say, because our 95% confidence interval includes 0, we have evidence that there is no relationship between the two. So what happened for this one? It was just a chance encounter this time that it was positive. Are there any questions? Did I go too fast? All right, we are done. I will post a homework assignment. It's only 2 questions over this. Okay, I'll modify it for everyone, even though the test didn't go very well. But please have that done over the weekend, as well as please also get your day problems done. So you need to do day 2, 3, and 4. Maybe start right now with day 2. There's still 6 minutes. You can at least do the submission piece. All right. Well, if you haven't done day 1, do day 1.